right. All right, so here's your first proof. Given that AR is congruent to LR and PR is congruent to IR, we are going to prove that AS is congruent to LS. Okay, and here's your picture. Oh, taking it with me. Oh my goodness. There we go. This uploads to YouTube easy, so I don't know how to do that with Notability. All right, here's the deal. If you look at the information they gave you, okay, this is an 8-step proof. There's a little bit of work involved here. You need to look at, yes, 8. Given, one of them is the given, which is number 1. So you have to look at what we know. AR is congruent to LR, right? But then they also tell you that PR is congruent to IR, okay? So if you look at those two sets of segments, the two triangles that they are a part of are these two triangles. So this is where we're going to start. This is R. We're going to mark it. That's why you redraw the triangle, so you can remark it. You can mark it on there. So this is R, this is P, this is L. Okay, so they told us AR congruent to LR and PR congruent to IR. Okay, so we know this information right now. What did I say always shows up in overlapping triangles? Reflexive. Do you see something that's reflexive in this one? Angle R. Okay, so for our first step, we're going to do the given. For our second step, we're going to say angle R is congruent to angle R because it's reflexive. Okay, so this angle here congruent to this angle here, that's this angle up there. Okay, what can I say is true at this point? What are? The triangles, right? We can say triangle ARI is congruent to triangle LRP by SAS. Oops, I don't know why I put that S there. Okay, so we know those two triangles are congruent, but look at what they're asking us to prove. They're asking us to prove AS congruent to LS. That is this segment congruent to this segment, which are not segments on the triangles we just drew, right? That would be like this portion of it with this portion of it. We can't say anything about that, okay? So instead, now what you have to do is you have to move on to two different triangles to get to that point. Because we know these are congruent, then if you look at these two triangles up top here, okay, so those two, we're going to redraw those now. This is P, S, I, L, and A. Okay? Because you have to prove that they're true. Prove. Okay, so in this setup now, we have AS and LS. Okay? Here's the beauty of it. This angle right here is this angle right here. Right? This angle here is this angle here. How do I know that these two angles are congruent?
Because those angles are congruent because
CPCTC. So I'm going to say angle PAS is congruent to angle ILS by CPCTC, right? Because they are part of the two triangles we already proved are congruent. So we can use CPCTC, okay? Well, that means that I can mark them here also. Do you see anything else in these two triangles that are congruent?
Angle PSA and angle ISL.
Right, these two angles here. Why are those congruent?
Vertical angles are congruent.
Vertical. So angle PSA is congruent to angle ISL because of vertical angles. Sorry for the mess. And then this last one's a little tough. If you think about what they told us at the beginning, okay? They told us this segment at the very top, okay? This red segment congruent to this red segment.
That means at the bottom.
But they also told us that this piece of it is congruent to this piece of it.
Which means the other piece.
So these two pieces also have to be congruent. Do you remember what that is? When the two parts have to equal the whole thing?
Isosceles.
Segment addition postulate. Right. So we're going to say PA congruent to IL
I say
by the segment addition postulate. Okay? Now look at your triangles. What do you see?
AAS.
AAS. Angle, angle, side. We can say triangle PSA is congruent to triangle ISL by AAS, which means now that they want us to say AS, so this segment congruent to this segment, we can say that by CPCTC. Okay, so notice two different sets of triangles, right? That's what you're going to see a lot in these guys.
Wait, didn't we
Look
already
for the different sets. Didn't we already know what? No? Okay. Okay, second final proof. If you follow along in the book on these, this one's different than the one the book gave. So don't wig out on me. AE congruent to BE. And angle C congruent to angle D is our given. And they are asking us to prove AD congruent to BC. Any thoughts as to what our last step will likely be? CPCTC, because we're proving parts of triangles congruent. Okay? So here's your picture. I know. We ran out of time in my last class, too. Yeah. All right. So this is our setup. First thing we're going to look at is the fact that they told us that AE is congruent to BE. Okay, so if you look here, this piece is congruent to this piece. What do you see knowing that those are congruent? It's an isosceles triangle, okay? So you can use that as part of your proof to say, well, let's draw the other two triangles real quick. So the two overlapping triangles we're going to draw are these. This is D, B, A. And this is B, A, C. Okay? So first step is you're given. I'm going to sneeze. Second step, we can say that these two angles. No, I lied. Not those two. These two angles are congruent. So angle BAD is congruent to angle ABC because we said they are isosceles triangles, right? This is an isosceles triangle. So that is isosceles triangle theorem. Don't pack up. I'm not done. Third thing we can say is that AB is reflexive. So AB congruent to AB. That's reflexive. Okay. And then in the given, they told us that angle C is congruent to angle D, which you should have marked, which I didn't. So the triangles are congruent by what? AAS. So we can say triangle ABD is congruent to triangle. So ABD is BAC by angle, side. So how do I know that AD is congruent to BC? AD is congruent to BC by CPCTC. Okay? Any questions on that?
Wait, I thought it was the 8 step.
8 was the last one. This one was only 5. Okay,
Oh.
we made it through. That is it.